Hello, I'm David Verghese, and at Cadence, I'm part of the latest product in the next generation Spectre simulation platform called the Spectre FMC Analysis. Spectre FMC Analysis offers the capability to perform fast Monte Carlo analysis and is the first machine learning-based technology integrated in the Spectre simulation platform. The underlying simulation engine for Spectre FMC Analysis is the industry-leading Spectre X simulator. Let's look at the problem statement. Aggressive technology node scaling has been going on for years in the semiconductor industry, but ensuring good enough yield is more complicated now. Why is that? First, operational characteristics of the transistor are getting more sensitive to variations in the manufacturing process, causing design failures. Second, significant increase in the number of PVD corners. And third, statistical variation analysis through millions of Monte Carlo simulations involving vast sample space and high dimensions. At the end of the day, the purpose of aggressive technology scaling is not met unless a high yield is ensured and verified. And doing billions of Monte Carlo simulations, even with the availability of large cloud computing resources, is not practical. So how can the designers accomplish this high yield verification and sigma analysis requirements in a much faster and efficient way without compromising on accuracy? This is where the Spectre FMC analysis comes in. Our Spectre R&D team integrated a new advanced machine learning-based kernel inside the Spectre core platform that allows the designer to do two tasks. One, fast exploration and learning of the hyperspace with a very minimal number of Monte Carlo simulations, allowing quick identification and debugging of worse samples causing design failures. Two, fast yield estimation in terms of a sigma failure rate along with uncertainty bounds in the form of confidence intervals. This provides quick yield analysis across multiple corners and designs in high volume yield verification production runs. Let's take a look at the applications of Spectre FMC analysis. Spectre FMC analysis technology can be applied to any circuit design type, ranging from RF, analog, I/O cells, bit cells, standard cells, memory, and even larger subsystems. Let me walk you through the 4 key benefits of this technology. 1. Accuracy and performance. 2. Support for multiple flows. 3. Ease of use and debugging. And finally, distributed processing. Let's look at accuracy and performance first. Spectre FMC analysis has been tested and verified with more than 500 million simulations to ensure that it has excellent SPICE-level accuracy and performance. Let's look at few results. For an advanced node standard cell, Spectre FMC analysis needed only 1064 simulations for 4.7 sigma verification from 10 million Monte Carlo samples. And similarly, for a bit cell, only 2,500 simulations were needed. In both examples, we can see that it is SPICE accurate and 400x to 10,000x faster in finding worst-tail samples from large distributions, avoiding the need to do millions of simulations. Also note that the distribution of measurement of interest need not be normal or continuous. Here is another example from a FinFET-based ADC design for 3 sigma verification. Spectre FMC analysis took only 900 simulations for a 10x speedup, avoiding 10,000 Monte Carlo simulations. And after 3 sigma verification, doing a 4 sigma verification needs only a few incremental simulations. Now let's look at the flows that support Spectre FMC analysis. The most obvious is the netlist-based command line flows using Spectre X simulator for high sigma analysis on standard cells, bit cells, or any kind of memory blocks such as SRAM or DRAM. Next is the Cadence Virtuoso ADE suite, the industry-leading cockpit for analog design and simulation environment, and I'll give more details on it in a bit. Third is the Cadence characterization flows. This includes Liberate Trio MX, and Liberate Trio AMS for very fast and accurate LVF generation for standard cells, memories, and AMS designs respectively. Finally, there is the Cadence Tempest timing flow for static timing analysis. The third of the 4 benefits is ease of use and debugging. The machine learning-based technology enables productive exploration and analysis of a hyperspace using several new features, like the Sigma sweep that captures circuit functionality trends from 3 sigma to 6 sigma, the moments estimation from the distribution, insight into the top mismatch device contributors and sensitivity analysis, an analysis with a fixed simulation budget and incrementally. And like I said before, since the technology is built on top of the core Spectre Monte Carlo engine, it's easier to identify the exact failed sample Monte Carlo iteration number and reproduce the failure to fix and improve the yield. Here is where I'm going to expand on the Spectre FMC analysis full integration into the Virtuoso ADE suite that I mentioned earlier. You can easily use the Virtuoso ADE Explorer and Assembler's existing specifications and test benches for statistical variation-based simulations with Spectre FMC analysis. After the Spectre FMC simulations, viewing consolidated results, pass-fail status, run logs, plotting waveforms can be done from the Virtuoso ADE suite. This also includes the ability to create a statistical corner for any simulated point and viewing of the tail samples in a detailed transpose table. And finally, distributed processing. The fourth benefit is distributed processing, from distributing simulations to distributing memory and computation needed to explore a very large sample space with thousands of statistical variables. It can be done with both command line and Virtuoso ADC suite use models. So to conclude, Spectre FMC analysis adds a new dimension to the Spectre simulation platform. It's accurate and gives amazing performance from 10x to 10,000x speedup. It's supported in multiple flows, including the integration in Virtuoso ADE suite. Debugging yield is very easy using the Spectre FMC analysis features. And finally, Spectre FMC analysis leverages distributed processing extensively to enable large sample space exploration for high sigma analysis and yield verification. Please visit our website cadence.com for more information or contact the Cadence support team for an evaluation.